Good afternoon. Myself Vaibhav Phule from DYPCOE Akurdi. Today we are going to see numerical solution for differential equation. Under that we are going to see ODE, that is Ordinary Differential Equation, and by Taylor's method. So the problem is, I have solved whole the problem on the notebook so as to reduce the time. The problem is, find the value of y at x is equals to 0.1 for dy by dx is equals to x square into y minus 1, and given y at x is equals to 0 is 1. So we are going to write the given data first. Here they have given initial value of x, that is x0, as 0, and at that x0 value of y is given as 1. So that we are going to write as x0 is 0 and y0 is, they have given it as a 1. Then we have to find the value of yj at xj is equals to 0.1. Okay, then here I have written the equation, that is dy by dx, will refer it as y dash, or first derivative of y. Y dash is equals to x square y minus 1. So as per the Taylor series, or the Taylor series formula is, yg can be calculated as y0, that is value of y at x is equals to 0, that is 1. So yg plus h upon 1 factorial into y dash at x0 plus h square upon 2 factorial into y double dash at x0, that means second derivative of y at x0, then plus h cube h raised to 3 upon factorial 3 into third derivative of y at x0 plus h raised to 4 upon factorial 4 into fourth derivative of y at x0 plus so on, where h can be calculated as xj minus x0. So here our xj is 0.1 and x0 is 0, so h comes to be 0.1. Now let us calculate first derivative of y at x0, second derivative of y at x0, third derivative of y at x0, and so on. So first derivative of y, that is dy by dx, is already given x square y minus 1. So we'll just put the values. So first derivative of y at x0 is equals to, just we know that x is 0 here, so it's 0 square into 1, y is 1, minus 1, it will be minus 1. Now we have to calculate the second derivative of y from first derivative of y. So we are going to differentiate first derivative, that is x square y minus 1, with respect to x. So here we have to apply u into v rule for differentiation. So it will be first term as it is into second derivative of second term. So derivative of y with respect to x is y dash, that is dy by dx, plus derivative of first term, that is derivative of x square with respect to x is 2x, into second term as it is, and the derivative of minus 1, that is constants, will be 0. So second derivative we have calculated as x square into y dash plus 2x into y. Therefore we can calculate the second value of second derivative at x0 by putting all the values we know. X is 0 here and y dash is minus 1, whereas y is 0 here, sorry, y is 1 here. So we can put all this value and we can calculate. So y second derivative at x0 comes to be 0. Then similarly we have to calculate third derivative of y. So third derivative of y is nothing but we have to again differentiate second derivative of with respect to x. So again we have to apply, we have to consider this as u and this as v. So again we will apply the same rule and we have to find the derivative. So first term as it is, derivative of y dash is y double dash, that is second derivative, plus derivative of first term is 2x into second term as it is. Again we have to apply, you have to consider u and v here. Again you can apply u into v rule for differentiation, and this, the derivative comes to be this. So you can add these two terms are 2x into y dash and 2x into y dash, so it will be 4x into y dash square. So let us try to find third derivative of y at x0. So just put, we know x is 0 here, y double dash we have already calculated as 0, then y dash is minus 1 and y is 1 here, already we know that y is 1, so it comes to be 2. Now again similarly we have to calculate fourth derivative of y, so that can be calculated from the third derivative of y. Again differentiate this equation with respect to x. Again use u into v rule for each and every term. You will get the derivative of fourth derivative of y as x square y triple dash third derivative plus 2x into second derivative plus 4x into second derivative plus 4 y dash plus 2 y dash. Again we have to calculate the value of fourth derivative of y at x0. So if you put all the values, we know all the values, it comes to be minus 6. Okay, and next again we will put all these values, calculated value, in the Taylor's formula, and the formula is yg equals to value of y at x0 plus h upon 1 factorial into first derivative of y at x0 plus h square upon 2 factorial into second derivative of y at x0 plus h raised to 3 upon 3 factorial into third derivative of y at x0 plus h raised to 4 upon factorial 4 plus fourth derivative of y at x is equals to 0, and so on. So if you put all the values here, h we have already calculated as 0.1, and if you put all the values and calculate this, if you solve this, then the value of yg comes to be 0.90033 at xg equals to 0.1. Thank you.